NASA engineers have begun testing the concept for a new propulsion system that could slash the time it takes for a spacecraft to reach interstellar space. This system would interact with particles released by the Sun, repelling protons to create thrust and achieve unprecedented speeds. Researchers say this could bring spacecraft to the heliopause in just 10 years, a feat that took the Voyager craft 35 years. The proposed concept is called the Heliopause Electrostatic Rapid Transit System (eSail) and works without built-in propellant. Instead, the eSail would be boosted by solar wind to reach the heliopause, the edge of our solar system. A slowly spinning spacecraft would deploy 10 to 20 electrically charged aluminum wires to create a massive eSail. Each wire would be just 1 millimeter thick but extend roughly 12.5 miles in length, almost the equivalent of 219 football fields. The eSail would repel the protons coursing through the solar wind, creating the thrust. The Sun releases protons and electrons into the solar wind at very high speeds, 400 to 750 kilometers per second, said Bruce Wakeman, an engineer in Marshall's Advanced Concepts Office and the principal investigator for the HERTS eSail. The eSail would use these protons to propel the spacecraft. Researchers at the Marshall Space Flight Center in Huntsville, Alabama have begun the tests which will continue for over 2 years. These will determine the amount of protons deflected by the wires and the amount of electrons attracted to them. The engineers will also conduct plasma testing and improve models of the data for further development of the eSail. The concept builds off an invention of Dr. Pekka Junhunen of the Finnish Meteorological Institute, but researchers say there is still much to be done, and it will likely be at least 10 years before it can be put to actual use. As its journey progresses, the effective area of the eSail would increase. At 1 AU its effective area would be roughly 232 square miles, but at 5 AU this would cover more than 463 miles. Typically, the energy of solar photons dissipates when a solar sailcraft reaches the asteroid belt at 5 AU, the researchers explain, causing acceleration to stop. But, it's thought that the eSail would continue to accelerate far beyond this point. The same concerns don't apply to the protons in the solar wind, Wakeman said. With the continuous flow of protons, and the increased area, the eSail will continue to accelerate to 16 to 20 AU, at least 3 times farther than the solar sail. This will create much higher speeds. When NASA's Voyager 1 crossed the heliopause into interstellar space in 2012, it was nearly 35 years into its journey. With this new method, a craft could achieve this in less than 1/3 of the time. Our investigation has shown that an interstellar probe mission propelled by an eSail could travel to the heliopause in just under 10 years, he said. This could revolutionize the scientific returns of these types of missions. While the design is suited to carry spacecraft past the heliopause, the researcher says it also has applications for exploration in our own solar system. As the team studied this concept, it became clear that the design is flexible and adaptable, said Wakeman. Mission and vehicle designers can trade off wire length, number of wires and voltage levels to fit their needs, interplanetary, outer planetary or heliopause. The eSail is very scalable,